This conference will now be recorded.
Yeah, so yesterday we have seen Redshift architecture followed by query processing, how the query will be processed in Redshift. And we also seen like what is the importance of MPP architecture and especially the distribution, importance of distribution. Okay, so although we may have distributed architecture, okay, distributed architecture means multiple nodes having the data is distributed to all the nodes. But if the data is not distributed evenly, we realize that it's of no use, obviously, right? So the very purpose of having distributed systems is that we can have the data equally distributed to all the nodes so that every node can process the data parallelly, thus reduce the processing time. But if the data is not distributed evenly, and let's say you're dumping all the data in one node, or you're dumping the most of the data, like 70% of the data or 80% of the data in single node, and the remaining nodes are empty, then only that node which has more data is end up working the entire work. Remaining will be idle. So here that means we are not utilizing the resources effectively. For example, you hired 4 laborers to do your work. Okay, so one among the labor is assigned, the 80% of the work, means more work, and remaining people are just there passing the time. You gave them small work. That means you are not utilizing them effectively. You see, everyone should be given equal work and everyone should be utilized efficiently. Or similarly, let's say you are working in a company, there are 4 employees, and 4 employees working for a project, and you are giving more work to one resource and the remaining 3 are just passing the time. That means what? Only one person is overburdened and he's working like daily 16 hours, and others are just coming and passing time and spending for 8 hours and going. And even that within that 8 hours also they are hardly working for 1 hour. So that's not proper utilization of the resources, right? So the same thing, if you are not distributing the data evenly to all the nodes means internally to the slices. It means even having distributed architecture is of no use. It's like, you're storing all the data in single node, then better you have single node architecture. And single node architecture will take more time. That is the reason we're going for distributed architecture. Okay, distributed architecture means you should make sure you are distributing the data evenly. Bus, you have to distribute the data evenly. Okay, otherwise the purpose of distributed architecture itself is lost. Okay, cool. So we have also introduced another term like skew. So this kind of uneven distribution of data across all the slices, I would say directly slices. Okay, I can say nodes, but internally it's getting distributed to slices, right? So that's all. So uneven distribution of data across all the slices is called skew. Okay, so skew is okay. Okay, up to 4% skew is okay. Means other slices can have 100% of the data, and one slice can have up to 96% of data, like that. So that means even, yeah, it's like almost even, because if you have 100 slices, it does not mean that you will have only 100 records to have one record for each. Sometimes you will have 105 records, you will have 200 records, you will have 95 records. So when you have 100 slices, you have 95 records, then only 95 slices will have one record. So 5 slices may not have any data. So that's why skew up to 95, 4 or 5% is okay. Okay, but yeah, if it is 0 is the ideal, but that is very rare case, but up to 5% is okay. But skew like 60%, 70%, 80%, 90% is really bad. Bad means what? Your data is completely unevenly distributed. So you're not taking advantage of the distributed systems. That means your queries will run longer because the slice which has more data will keep on working. Like we saw yesterday, one slice has 75 records and other slices has less data. So all the other slices completed very fast. I mean, in the beginning itself. But the slice which has more data, it's keep on working till end. So that means we have to design a way by which we can evenly distribute the data. Fine. That is what actually today's concept. The that is called actually Redshift table design in this concept. Redshift table design means how should we design the table in such a way that data will be evenly distributed. So Redshift table design. What is that? Redshift table design. Okay. How should we distribute the or how should we design the tables so that data will be evenly distributed? This one. Okay. So yeah, so that means how data can be distributed to all the tables will be discussed in the concept called Redshift table design. Okay, so how should we design the table so that data will be distributed? That's fine. Okay, so before going to this concept, we should know. I mean, we already know that Redshift is a columnar, right? Columnar storage. Okay, cool. So let's see what is that columnar storage. See, all databases, as I already said in the beginning classes, all databases. Actually, database means its storage will be rows and columns. Okay, so they are actually stored like this. See here, my cursor. Okay, so for example, if we have a table, okay, with SSN name, age, address, city, and street or state, yeah, state, it is state. Then all your data will be stored in the database like this. Entire record will be stored. And this entire record will be stored. Entire record will be stored at the disk level. Okay, disks are further divided. I mean, internally we call it as the blocks. Okay, see here. Let's say, yeah, I already said disks are small, internally divided into blocks, and in the blocks it will be decided generally in the data warehousing, or I mean in the IT, the blocks are generally like 1 MB. Okay, 1 MB. Okay, means data will be stored in 1 MB chunks. How many records will fit in 1 MB? That many records. Like that, multiple MBs will be occupied. I mean, multiple MBs is only GB, right? Multiple GBs is only TB, right? So that's all. So all your data will be stored in 1 MB blocks. You see, block 1, block 2, block 3. So, and Redshift also uses 1 MB blocks for storage. So, okay, if it is relational database, all the data will be stored in row level, means entire record will be placed and stored in the block level. For example, I will tell you, my data is 1 MB, right? So block size, let's say my record size is how many? 1 MB means how many KB? 1 MB means 1024 KB is 1 MB. Okay, 1024 KB is 1 MB. Okay, so let's say this is 1 MB. Then my record size means size of all the columns in a record. Okay, my record size is 100 KB. Okay, Okay, let's see. My record size. Record size means record means what? Row, right? So all columns length is 100k. Okay, k means kilobytes. Okay, so if one record size is 100k, okay, then how many records will fit in 1000k? 1000 kb means actually 1024. I will take it as a 1000 kb. 1000 kb means 1 MB. Okay, so if one record size is 100 kb, then how many records will fit in 1 MB or 1000 kb? How many records? Good. Yeah, 10 records. Because one record size is 100 kb or 100k, then you will have such kind of records, 10 records in 1 MB, because 1 MB means 1000 kb. Okay, if my one record size is only 10 kb, my one record size is only 10 kb, then how many records will fit in 1 MB?
100 records.
Yeah, 100. Right, Somnath?
Yes.
Yeah. So same. For example, my record size is only 1 kb. Then in 1 MB data block, how many records will fit in?
1000.
1000. Bus. Simple. Okay, cool. So now this is what the same calculation. Okay, so my block size will be 1 MB. Okay, so your records, if it is a row level storage, entire row will be stored in that 1 MB block. Like that, how many records will fit in? That many records will be there in first block. Then if that block is full, then remaining records will stored in another block, like that. So here let's say the record size is 1 MB itself. Means the size is large enough to 1 MB. That's why block 1 has, let's say, one record only in block 1. And the next record is the highlighted record 862. 892375 862 is there in block 2, and next record is there in block 3. Okay, so that is the way actually it is a row level storage. I'm just trying to explain what is a row level storage. Okay, so entire record will be there in each block. Column level storage means instead of entire row, only columns will be stored in the blocks. For example, here you see how many columns are there. SSN, name, age, address, city, state. So column means, you see here the highlighted block. SSN is the entire column. So all the SSN will be there in block 1. See here, block 1 has all the SSNs. See, in this it is only showed 3 records, but you see these are all SSNs. Okay, 4862, 4682, 48180, 3785. See numbers. Because how can I say these are all SSNs? You see, this data is not there in this table. See here, this data is not there in this table. So all are SSNs. So all SSNs are stored in block 1. Means I said right. If entire record is 1 MB, that means SSN is definitely one column is less than MB. So multiple SSN numbers will fit in 1 MB. Similarly, if this MB is this block 1 is full, then name will be there in stored in another block. Similarly, age values will be stored in another block. Address will be stored in another block. Like that, column level storage means column data will be stored in block wise, not the entire record data. Row level storage means entire record will be stored in each block. Column level storage means whole column values will be stored in each block. That's all. Is it clear? What is row level storage and column level storage? Row level means entire record will be stored in each block. Like that, based on row size, that many number of records will fit in. Column level storage means only columns a particular column will be stored in each block. So based on column size, it may accommodate more values. Is that clear? What is row level storage and column level storage?
Yes. Yes, sir.
Okay.
Sir, in
So now,
SSN column, 1,000 records is there. 1,000 records will be stored in block one, sir. Right, sir?
based on what is SSN length, SSN, if SSN size is 1 KB, okay,
Yes,
then
sir.
in 1 MB, how many? 1024 SSNs will fit in. If SSN is, you know, 10 KB, then 100 SSN numbers will fit in. Hello, you understand? Based on what is
Yes,
the SSN length.
yes, sir.
Okay. Now I can tell you even how to calculate. Actually, this is how to calculate length. For example, we create table, right? CREAT, create table. Create table. What is this table? Okay, citizen, SSN, and here integer. Okay, name varchar 20. So something like that, city, state, and all. See, integer means integer will occupy 4 bytes. You should know this is the underlying knowledge. I have not told you, but this is the next level of knowledge that you need to aware. How do we know SSN is how much size it will take? You will know because at the time of creating a table, you will create table like this, right? So SSN integer means that means each value will take 4 bytes. Now you tell me how many SSNs will fit in 1 MB block? Hello. And now I told you that integer means 4 bytes. Okay. Now you tell me how many SSNs will fit in 1 MB block? Somnath, can you tell me how to calculate?
Yeah, so 4 bytes. So
250, sir.
so we have to convert that into MB and then multiply.
Okay. Yeah, Prasad, you tell me.
250, sir.
Tell me how did you calculate?
1,000 by 4, sir. 4 bytes means.
I did not say integer will occupy 4 MBs. 4 bytes I
Sorry.
said. Integer will occupy only 4 bytes. I did not say integer will occupy some 4 KB or something.
Yes, yes.
So now you change this 1 MB. 1 MB means how many? 1024 KB. Okay. So 1024 KB.
2,500, sir.
So
2,500.
1024 KB into 1 KB equals to 1024 bytes. That means actually 1024 into 1024 bytes. Now it's in bytes. Okay, one MB means. Okay. Now what is the size of one SSN? 4 bytes. So 1024 into 1024 by 4 you should put. Means you are converting everything into bytes. Hello, Somnath, are you clear now?
Yes.
Yeah. So SSN integer. How do you decide the size of a particular column? Based on the data type. Data type integer will occupy 4 bytes. Small int will occupy 2 bytes. Okay, long int will occupy 8 bytes. Varchar 20 means 20 characters, 20 bytes. Date 10 bytes. This is the knowledge you need to know. Okay, I mean, generally you will know when you work on it. Okay, I mean, don't worry, you will know when you start working. So, SSN will have integers, so 4 bytes. So we know that 1 MB is the block size. So 1 MB you convert into bytes. 1 MB means 1024 KB, and 1024 KB means 1024 into 1024 bytes. By what is the size of one SSN? 4 bytes. So whatever it comes, that many records will fit here in that 1 MB. Okay, Prasad, you understand how many SSNs will fit in 1 MB now?
Yes, sir.
Yeah. Somnath, you are also clear, right?
Yes, sir.
Yeah. So that is the way we have to calculate. Now you tell me, for example, I said record size and record size, right? Can you tell me what is the record size of this table? I have only 2 columns. What is the record size of this table?
24 bytes, sir.
Yeah.
Integer is 4 bytes, where 20 bytes.
Yeah, right. So 24 bytes. So if you have 100 columns, you have to sum up the size of all the columns. That is the funda. Okay, how many columns are there? You should know what is the data type of each column, and you should know based on the data type how much size it will occupy, and you should add it up. That will give the size of the one record. You understand?
Yes.
Yes, sir.
Yeah. Let's say in this table I have 1000 records. 1000 records. Then can you tell me what is the size of this table? Size of this table.
1000 into 24.
Huh?
1000 into 24.
Yeah, that's all. This 24 is the B. So actually 24 KB, because 1000 means K, right? So, 1000 means K, right? Yeah. Actually 1024, yeah, but we take it as a 1000, okay? 1000 is a K. So this is 24 bytes. So actually 24 KB will be the size of the 100 records table. Or let's say I have 1024 records, okay? Yeah. So I have, we know that each record, I mean, 4 plus 20, 24 bytes is the record size. Then how many you have? 24 KB. Because 1024 means 1K, 24 records. That means 24, yeah, one record size is 24 bytes. Like that, you have 1024, 1024 records. So 24, I mean, you got it right. Hello, you
Yes.
understand what I want to say? Hello,
Yes, sir.
brother. Yeah, what about Prasad? Huh? Hello.
Yes, sir. Yes.
Anyway, yeah. So that's why I always try to take the round
Yes, sir. Yes.
figures, okay, to avoid the confusion. Yeah, okay, okay.
Yes, sir. Yes, sir.
Okay, that's the reason. Yeah, okay, okay. That's the reason I always take the round figures to avoid the confusion. So you have 1000 records, okay, and you know that each record size is 24 bytes. Then you will have actually 1000 into 24, okay, will be the table size. So actually it is 24,000 bytes actually, okay. So 24,000 bytes is actually, 24,000 divided by 1024 actually, okay. So yeah, we generally take 24,000 by 1000, yeah. So which is nothing but 24 KB. Okay, because why I divided with 1000 to convert into kilobytes. Okay, take the first 3 zeros to convert into kilobytes. So 24 KB will be your table size. Like that, in the real time, we also will calculate the table size. Okay, so everything comes from this table definition based on the data type. Okay, you can calculate record column size, table size, record size, everything. Fine. So yeah, now why all the cloud data warehouses come up with the columnar storage? Okay, so earlier, yeah, since since long time, everyone is using row level storage. Okay, but suddenly why all the cloud data warehouses or modern databases are coming up with the column level storage? Okay, so I have already told you one point, that companies have acknowledged that there is a issue with the row level storage. Okay, so and that is the reason all modern data warehouses or cloud data warehouses are coming up with column level storage. I'll tell you what is that issue. Issue is there is a IO problem, IO, input output. For example, you want to, okay, you want SSN, okay, see this that 89237586 only that SSN, okay, from this table, citizen table. Selects, okay, SSN from, okay, citizen, where SSN equals to this number you gave. Then what happens, in row level storage, it will fetch all the record into temporary, generally intermediate space, we generally call temporary memory, and then our memory, and then it will take the SSN number. That means it unnecessarily bringing the all other columns during processing to fetch the required data. Because why it's bringing the entire record? Because it is stored entire record wise. That's the reason it is fetching the entire data into main memory, from disk to main memory, and then it fetches whatever values you need, and it will return that result to the end user. Generally in real time we have many columns, 20, 30, 40, even I have seen 200 columns. Okay, so 200 columns in a, then but in the select list you hardly need some 2 columns, okay, or sometimes even 1 column. So you need only 1 column, but what happening internally, it is fetching the entire record into memory before fetching that 1 value. Why it is fetching entire record? Because it is stored entire record wise at the disk space. It is stored record wise, so it has to bring the entire record in order to give whatever column you need. That is the reason. That means it has to fetch the entire record, which has maybe 100 columns or 200 columns. So more IO will be spent there. So the traditional databases are facing that IO exhaustion problem. Okay, IO issue. So, but if it is stored, it is in columnar storage, and you want only SSN, then select SSN from citizen table where SSN equals to 892375. Then it will just comes to this block 1, and it will bring that SSN number. That's all, because it's already stored SSN wise only. It is not unnecessarily fetching any other values, because it's already stored at the column level. Am I clear? What is the issue with row level storage? What is the issue benefit with columnar storage?
Yes, sir.
Somnath, you are also clear, right?
Yes.
Yeah. So that's the reason. Basically, it saves a lot. Saves a lot of IO means what? Saves a lot of performance. How difficult it is to bring a column, a table which has hundreds of columns during query processing. There itself, all the time is lost. But if it has to bring only the columns that are required, rather than fetching the entire record. It saves a lot of time and CPU and IO during the query processing. Thus, it will be faster actually. Okay, cool. So now is a columnar storage is optimizing analytic query performance because reduces the overall disk IO requirement. Yeah, because here you are not unnecessarily pulling any columns other than what you need, because here the storage is based on column level, so you will be fetching the required columns directly. You don't have to pull the entire record into memory and then take your required values. Okay, reduce the amount of data that you need to load from the disk. Yeah, so whatever columns you need, you will be pulling only those values. You are not pulling other columns or other part of the entire record into the memory from the disk. Okay, each block holds the same type of data. Yeah, this is, you see here, this block one, it has all SSN numbers. Means all SSN numbers means all integers. But so that will make even much more faster. But whereas here you see, you are storing in the entire record, and in this record, different data types. SSN has integer, name has varchar, age integer, address again maybe varchar or character, city character, street character, and if you have some dates and all, that's again date. So you will have multiple data types involved. So that will also slow down the process. Okay, next. Block data can use a compression scheme selected specifically for the column data type. Yeah. So compression, here the term is compression. We'll talk about it later. So compression means, right, compress, zip. We try to zip files, when you want to send mail. If the size is too big, what you will do? You will do compress and then attach. Similarly, tables, if they are too big, in real time also, there is a concept called compression. Compress the data at the disk level so that you can save the disk space, because in real time we are playing with terabytes of data. So, and some tables are too big. So if table size is too big, what happen if your attachment size is too big? For attachment itself, it will keep on attaching, but it's not attaching. It's taking time, right, when you attach to Yahoo Mail or Gmail, because of the huge size. But if you zip, the size is compressed, so size is reduced, so it will immediately attach. Same thing. If the table size is too big, during query processing to retrieve the data, it will take more time. So it will take query processing slow. It will make query processing slow. So, but if you compress, it will be easy and faster for query processing. So this is what this point. Block data can use a compression scheme selected specifically for the column data type. So that means here the data is stored column wise. So here all integers. So compression will be faster because all are same data type. And for example, name will be stored in another block with all varchar. So it will be faster because all are same data type. But here you see it has different data types in the same record. So compression will not be much efficient here. So compression is also one of the main benefit of the modern databases. Okay, so yeah, so all these are the benefits of the columnar storage. Yeah, this I told you just for your detailed understanding. But generally, what is columnar storage? Columnar storage means data will be stored column wise. Bus. Row level storage means data will be stored, entire record will be stored at the disk level. What is the disadvantage of the row level storage? Because it has to fetch the entire record during query processing, which will actually slow down the process and takes a lot of IO. Whereas in column level storage, because that is already stored at the column level, so it will only fetch the directly what that is required or what columns are required. So it avoids the IO consumption, or it will not take much IO because we are not fetching in unnecessary data. Yes. Okay.
Yes.
Yes, sir. Yes, sir.
Okay. Cool. So next. This compression and statistics is a separate concept. I will touch upon it later. Okay. Compression and statistics. I mean, these are important concepts and separate concepts. Okay. So now, as part of our discussion, we are talking about distribution, right? Tables should be distributed evenly, and this is the most important concepts in the entire Redshift. Okay. So Redshift table design. In the net, you will get Redshift advanced table design. That is the term. If you search, you will get Redshift advanced table design. Actually, so this is called advanced because this is the actually most important part of the entire Redshift. Actually, very simple, but most important. Okay. So okay. Okay. So here we are talking about distributing the data to all the slices is very important. Okay. And if we are not distributing, we are saying that it's leading to skew. Yesterday Prasad is asking like how to avoid that skew. How do you avoid that skew? You should avoid that uneven distribution of data. I mean, that's what actually skew. Skew means uneven distribution of data. So you should avoid skew means you should avoid uneven distribution of data. That means you should distribute the data evenly. Okay. How can you distribute the data evenly? So how can you distribute the data evenly means no. Okay. So how the Redshift distributes the data is, see, actually when we create table in Redshift, we'll create like this. Okay. So create table, same thing like whatever we do in Oracle or I mean whatever database, same only, but little different. See here, create table department number integer, department name, okay, where department location where here. You see in Oracle you will have here primary key, okay, primary key, department number, okay, and of course, and that's all. Here you will have something like foreign key and all, okay, if you have foreign keys. So now which database you have an idea?
Postgres.
Oh, Postgres. Okay, nice. Then you almost know Redshift. Almost means you already know 80% of the Redshift because it built on top of the Postgres. So yeah, you are good. You're already there. Okay, so cool. But you need to know like what is this Redshift and how it operates because it made that architectural changes, right? At the bottom level itself, ground level. Yeah, actually there is nothing like distribution keys and all in Postgres. So these are the things actually people from Postgres need to know. Okay, cool. So here we will introduce or the Redshift means we should be deciding or defining distribution style, key, and some column here, or distribution style all, okay, or distribution style even, distribution style auto, like that we will be mentioning here. Okay. So same everything's create table name, list of columns, and you will close the bracket. And here you will define distribution style key or distribution style all, distribution style even, distribution style auto. You will be mentioning one of these things. Yeah, sort key, of course, if required, you will define, otherwise you don't define. Forget about it for now. Okay. So here distribution style key or all or auto or even. We will define like this. Okay. So what does it mean? Key, all, auto, or even? So that's what we need to know. Actually, when we define a table with a distribution style, okay, either key or all or auto or even, actually this key is the one which will be actually distributed to all the slices, because we say that in distributed architectures data will be distributed to all these slices, right? So on what basis data will be distributed? On what basis is this is the base? We will be defining a distribution style, some column, and that column is the one based on that column data will be distributed. That's all. You take Teradata also MPP architecture. I mean, Teradata is on-premises database, but it is already using MPP architecture. So there also we define primary index. So based on primary index, data will be distributed. And in all cloud data warehouses, there is something like distribution style. Okay, only name may change. Okay, you see in Teradata they call primary index, in Redshift they call distribution style key, and distribution style key. But in Azure they may name something. In BigQuery, Google BigQuery they may name something. But the purpose is to distribute the data to all the nodes. That will not go anywhere, because that's what the distributed system sees. Because you need to distribute the data, so the name may change, but what you do is same. So there are Redshift. We are studying about Redshift. So Redshift has these 4 distribution styles: key, all, even, auto. Key means whenever you define key, you will mention one column name here. Something like when you define primary key, you will give column name, right? Something like employee ID. Similarly, when you style distribution key, you will define some column name. So when you define that column name, this column values, because department will have some values, right? So all these values will be evenly distributed to all the slices bus. Okay. So this department number, all values are unique. Generally, for every table, there is some column which is unique, right? For employee table, employee ID is unique. For department table, department number is unique. Similarly, for customer table, customer ID is unique. For orders table, order number is unique. Similarly, for any table, some column will be unique. So if you define that column as the distribution key, that will evenly distribute the data. But if there are duplicates in that key, all duplicate values will go to same slice. You should know. Only unique values will go to, or unique values will be distributed uniquely or evenly. If there are duplicate values, all values will go to same slice. That is the point you need to note. That means you should select the distribution key in such a way that the column which is most unique. If it is unique, your data will be uniquely distributed. If it's not unique, I mean, if it has more duplicates, all the duplicate data will be going to same slice. Are you clear on that?
Sir, what is the meaning of a disk T key, sir?
Yeah, that is the syntax. Okay, this, I mean, it is not disk key, it is disk key. Okay, distribution style key.
Yes.
Yeah, I
Okay,
will show
okay,
you.
sir.
I will. Yeah, I will show you that. Yeah, this is the concept we are talking about. So the syntax is here. This is the syntax. Okay, we'll write like this: distribution style key, dist key. Okay. Okay.
Yes, yes, sir.
Yeah. So generally, even when we create a table, yeah, primary key, employee ID. I mean, create table, employee, employee ID, employee name, department number, salary. Close the bracket. Primary key. We define some column, right? So employee ID or something. Similarly here. Okay. Dist style key. Actually, dist key will be actually the name of this dist style, whatever you want to give, dist style or dist key location. Because on primary key also we can give. Anyway, we will be creating them, okay, as part of our lab or something. Okay, so distribution style key. Okay, so you will be defining as dist key and some column name. What column you on what column you will be creating. So only for dist key, that is the syntax. Okay, for distribution style key, dist key location. So that means location, based on the location, your data will be distributed to all the slices. But if you give distribution style key, dist key AID, okay, AID, here you see AID, audience ID. Then based on AID, data will be distributed. But if you give dist style key, dist key, date, DT, here you see DT. Then based on date, your data will be distributed. So on whatever column you define as the dist key, based on that column, your data will be distributed to all the slices. Bus. And here the point to be noted, if that column, whatever you mention, if that is unique, your data will be evenly distributed. If it has a non-unique, means if it has duplicates, all the duplicated data only will go to same slices. That means, for example, you see, yeah, here you have given location, okay. So if this table has 100 million records, and in that 100 million records, okay, 90 million records are unique. Okay, 90 million are unique. So those 90 million records will be evenly distributed. But one particular value repeated 10 million times. Then all the 10 million records will go to same slice. That means if any value of the distribution key is duplicate, then all duplicate values will go to same slice. That means those duplicates will go to same slice, so it will lead to skew. So that is the reason you have to make sure you select the distribution key which is most unique. Okay, which is most unique. So if there are any duplicate records in that, all the duplicates will go to same slice. So it may lead to skew. But yeah, if it is too many duplicates, then only it is skew. If it is less than that 5%, I said, right, tolerance level 5%, then you are good. Okay, so we cannot expect 100% unique. So let us be practical. So up to 5% skew is okay, because any value will have some duplicates, but it should not be too much duplicate. That is my question. That is my point. Are you clear with the distribution style key? When you define a distribution style key, based on the key values, data will be distributed evenly. So the more unique the values, that much evenly data will be distributed. If it is there any duplicate values in that value, all the duplicate values will go to same slice, and that's what we generally, we are calling as the skew. But if that is within the tolerant limit, that's fine. But we should make sure that there is no much duplicates in the distribution key column. Are you good on this? What is distribution style key?
Yes.
Yes, sir.
Okay. So this is the syntax for this. Create table in Redshift. Create table name. your column data type, column data type, column data type. Dist style is the keyword you have to use. Key and dist key, whatever key you want to give, you can give it. Okay. Then you see here for event, yeah, same thing, dist style, event. Okay. So you have to mention all auto. Similarly, for this is all. Dist style all. You will be mentioning all. Okay. And auto, dist style auto you will be mentioning in case of auto. Okay. I mean auto. If you don't mention anything, it will take automatically auto. You don't have to exclusively mention anything. Auto. Okay. So if you don't mention anything, it will take auto. Okay. But for other things, you have to mention dist style all, dist style key, and dist key. Okay. And dist style event. You have to mention. If you don't mention anything, it will take this style auto. Okay, cool. Now I will tell you. Now you know key means what happens. Key means what happens. Based on the key, data will be distributed. All right. So yeah. See here, example 2. Oh yeah, very nice example. Location. See here. Yeah. Node 1, node 2. Okay, you have two nodes. Okay, each node you have two slices. Slice 0, slice 1, slice 2, slice. I mean, actually, they will give number like that. 0, 1, 2, 3. 4 slices you have in two nodes. Okay, 2, 2. And here, what is the distribution style? Key, dist key, location. Okay, what I said, if location is unique, your data will be evenly distributed. But if your location has any duplicates, duplicate values will go to same slice. See here, this location, this SFO, JF, JFK, SFO, JF. You see here, only one value repeated two times, SFO, SFO, JFK, JFK. So SFOs will go to one slice, JFKs will go to other slice. So see here, wait. You see, only slice 0, slice 1 has the data. Slice 2, slice 3 they don't have data. Okay, that means SFOs all went to one slice and JFKs all went to another slice. And there is no more unique values, so there is no records in slice 2 and slice 3. Because, I mean, definitely location we cannot expect unique values. So like this situation can come. In fact, it came. But see the second example, AID, okay, audience ID. Generally, IDs will be unique. In fact, in this example also, it's 1, 2, 3, 4. It's unique. So you see, that is evenly distributed to all the slices. Every slice has data. So yeah, that's what I was saying. The more unique your data will be, the more unique the distribution key, your data will be distributed evenly. The more non-unique, the all non-unique values will go to same slice. Okay, so that is about the key. All means, now I'll talk about all. Distribution style, all. You see, this is the syntax you will write. Create table name, list of columns followed by the data types. Okay, and this style all. In all means, what happens is your the whatever data you're inserting, the entire copy of the data is present in the first slice, where the first slice of each node. Here, how many nodes you have? How many nodes you have? Two nodes, node 1, node 2. And in node 1, how many slices you have? 1, 2. 1, you have only 2 slices. So entire copy of the data is present in the first slice of the node, each node. So in node 1, it will put all your data, and in node 2 also it will put all the data. Where it will put in the first slice. That's what all distribution style, that is the way it will work. What happens when you define a table with distribution style all, the entire copy of the data will be stored in the first slice of each node. That is the statement.
Sir.
The entire copy of the data will be present in the first slice of each node. Yeah, tell
Sir,
me.
sir. Yeah, in slice 0, slice 2, same data will be stored, sir.
Yeah, entire copy of the data is said, right? So
Two
entire
copies.
file. Yeah, since here we have only 2 nodes, 2 copies. If you have 5 nodes, yes, it will be there in every node. First slice, you will have the data. You try to understand my
Okay, sir.
point statement. Entire copy of the data is present in first slice of each node. Means if you have 10 nodes, in every node, first slice, it will have the copy of the data. If you have 100 nodes, yes, in all the 100 nodes, in first slice, it will place the data. Here you have only 2 nodes. So in the first slice of each node, you have the copy of the data. If you have 20 nodes, yes, in every node, first slice, it will place the entire copy of the data in all distribution style. Any question for all distribution style?
No, sir.
Somna, you are clear?
Yes, sir. Yeah. Got it.
Okay. So this is about all distribution style. So it will place entire copy of the data in the first slice of each node. So same copy, okay? All means what? Entire copy means same full file, it will place in the first slice. So basically this, generally, now people may ask, sir, why it is placing, and actually it is duplicating, right, sir? Yes, it's duplicating. That is the reason it is ideal only for small tables. Okay, for small tables, all is advised because it's anyway a small file, so it's worth keeping the copy in this in one of the slice of the entire node and every node. So as a thumb rule, it is keeping in the first slice of every node so that it will help during the joins. Okay, so generally all is ideal for small tables. That is the point to be noted, because it makes a copy of the entire file in first slice of each node. So if it is a big table, duplicating such a big table in every node is not recommended. In fact, you cannot make such a big file. It will take a lot of time and lot of resources. So all is ideal for small tables. Okay, next one, even. So generally, if you know which column is unique, you will create distribution style. This key. You will create distribution style key. Okay. So, or if you know the table is small, you will define it as all. Okay. Or if you don't know, you will just leave it. Okay. So initially it will become auto. Auto. Auto, how it process, initially it will starts with all and then it will become even. Okay, cool. What happens in the even? That means what I said till now, if you know which column is unique, try to create as a distribution style key and give that key column. It will distribute based on the key column. If you know if the table is small, you can create it as all. If you don't know, you can just leave it. Or if you give even distribution style, what happens is that even will just distribute in round robin fashion. Round robin means 1 2 3 4 1 2 3 4. Okay, equally it will distributes and goes. Okay, for example, here, how many slices you have? 4 slices, right? 2 nodes, each node has 2 slices, so 4. So let's say here you have only 4 records, so 1, 2, 3, 4. Then let's say here you have 40 records, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, like that, round robin, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Like that, it will distribute equally. So basically,
Even if there
even
is
also
duplicate,
will distribute. Yeah, even there is duplicates.
so duplicates will be in different slices.
Sorry.
So if there are duplicates, duplicates will be there in different slices because it is going in round
Yeah,
robin fashion.
yeah, that's what I'm saying. Round robin means what? You just distribute and go. Just distribute and go. Don't worry whether it has duplicate or same key or different key, or whether it's a small table or big table. No. Round robin means 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Whether it's the same record or different record, it doesn't matter. You don't look all those things. Okay. Somnath.
Yes, sir.
Yeah. So even distribution. So I mean, somebody may say that. I mean, generally people. I mean, people with less experience, or people who did not work much on database or distributed systems, or those people who did not work much on performance. So they may think that, oh, even is better than, because it is equally distributing. For distribution, it may be good, but during joins, it's not good. Okay, because for joins you need matching. Anyway, that's a big concept. I will tell you in separate class. I mean, what is the importance of distribution style for join purpose? Or finally, to join, you should have matching values, right? For example, you see here in you are joining, okay, employee department tables on department number. In slice 1 you have department number 10, okay, and in slice 3 you have department number 10. How do you join them if they are not? They are in two different slices. See, in slice 0 you have department number 10 of one of the employee, okay, and in slice 3 you have department number 10. Then how do you join these two? They are not in the same node either. If there is same node, then of course that's a different thing, but they are in different node. But since department number 10 and department number 10 is matching, so you should join them. So how do you join? So okay, how do you join is either you have to bring this department number 10 to here, or you have to bring this department number 10 records to here, or you have to bring both the records into some other, okay, outer space somewhere here, and you join here. For example, you see you are in UP, I am in AP. How do we join if you want to exchange? I mean, we need to meet. Join means what? Matching values only will be fetched, right? So yeah, we have matching values, but we are not in same place. Either I have to come to you, or either you have to come to me, or we have to meet a particular place which is close to each other, maybe somewhere outside. Maybe if you're close, also close to Hyderabad, we can come to Hyderabad and meet, or someplace which is equally distant for both of you. Same thing. Okay, so you have, okay, employee table is there, department table is there. If they are in same node, that's fine. They would have easily joined there. But in slice 0, employee record of department number 10 is there, and in slice 3, department number 10 is there from department table. But how do you join? They are not in same node. So either you have to take department table into this node 1, or you have to bring this employee table into node 2, or you have to bring both the records into somewhere outside, and you have, so same thing. If you are in same city, we can easily meet, right? I mean, the same city means what? I can come to your home or you can come to my home, no problem. But if you are two different cities, Either I have to come to your city, or either you have to come to my city, or we should go together, go to some other city which is close to both of us. Same thing. That's why just because even will distribute data evenly, we should not create even. It will distribute evenly, but it will give problems during query processing. Okay, so how we should give or how we should distribute the data means, yes, evenly. I mean, evenly means equally we should distribute, but we should make sure that joins, it also will make the joins easier. Okay, that's why we should always try to create distribution style based on key column. Key column, generally key columns are joining columns, so that will help. Okay, even if it is little, generally key columns are not that much duplicate, right? Key columns are not that much duplicate, so that will take care everything. But it's not advised to create even. It is the last priority. See here, was first I said distribution style key, then all, then if you don't know, you create auto. I did not say create even. So even is the last priority. And especially for what tables it will create is the tables which are not used in your day-to-day queries, or which are not used in query processing or for your reporting. Means generally some history tables or something, and you are not going to use them. So then of course you can create them even, so that they will be evenly distributed and it will not waste your space. They will just lie there. Okay, but for your queries which are used in your day-to-day reporting or query processing, as a distribution style key or even should be created. Okay, so if you don't know, just keep it as, or don't define anything, it will automatically take auto.
In auto, how it will
Is
distribute?
that
Like automatically it will just distribute.
auto? Yeah, wait. Yeah, in auto, how it will distribute is, initially it will start with all. Okay, auto, if you, I mean, if you don't define anything, it will create it as auto. Auto, how it function is, initially it will create with all. All means you, I mean, why you created it auto? Because you don't know whether this is a big table or small table, or what column is unique, which is used in the join, and all those things you don't know. So you will create auto. Auto will always first create with all, because any table will go from beginning from small only, right? So it will create with all. All means it will keep the entire copy of the data in the first slice of each node. Okay, once it comes to know that yes, this table is too big, then it will convert that to even. Means it will evenly distribute. Okay, so now,
Yes.
yeah. So
Yeah. Hello.
yeah.
Yeah.
So yeah, got it.
Yes. Yes.
So study about them, about distribution styles. Okay, I mean, I told you, right? Type the Redshift advanced table design. Okay, yeah, there is a, in fact there is a Redshift, I mean, AWS playbook on this. Okay, Redshift advanced table design playbook will be there, and he will talk about these things only. Okay, very important, and I will talk about this more on subsequent classes with respect to performance. That is the reason it is too important, because all the performance will depend on these distribution styles. Okay, and yeah, that requires detailed explanation how it impacts the performance, that we will be discussing in next session. Okay, so why we should take key, or which column we should take key, and how it will impact in the joins, or how we should take all, or how it impacts in the joins. Okay, or how we should take auto. I mean, auto means you already said, right? It will start with all, and once it comes to know that, it will automatically converts that all to even. That is the way it will work. Okay, Okay, fine. Any questions?
Sir, sir,
So,
once again tell me auto.
Auto
Auto.
means you see here. Here, right? This is your table. You don't define anything. You just create like this. Okay. I did not mention anything. Then it will create the distribution style as auto. You see, if you create like this and you see the table DDL, okay, then you will see like this style. You will see like this. You see, you did not create it like this. Okay, you create it like this. Okay, you will run like this and you will run it. But when you see the table DDL, it will show like this. That means if you don't mention anything, it will create with auto. So auto means what happens is that initially it will operate with all. All means all the data of this table. I mean, whatever you are trying to insert into this table will be placed in the first slice of each node. That's what all, right? All means how it works. Entire copy of the data will be placed in the first slice of each node. Okay, cool. So later, if it, I mean, I already said if the table is small, then only all is good. So if it come to know that if the table is too big, it will come to know, right, as we are loading data every day. Then it will change the distribution style from all to even. Even means it will just distribute the data round robin fashion to all the slices because it found the table is expanding too big. Is that clear,
so
Prasad?
for small,
Yes, yes, sir.
so for small tables, why all is better? Like if it distributes to all the data in all nodes, yes, and the computation will be there. Same computation will be there on the same data, right? In all the nodes. Then, what is the use case?
Okay. Yeah, tell me. Sorry, can you repeat again?
So, for all, what it happens is the data is distributed. Same data is there in all the slice, all the first slice of every node. So, if I have any query running on that data, so that will uh, run on all the nodes, right? The same, and the processing will be done on the same data again and again. So I didn't understand that part because if I do some count star will run here also in here slice 2 also. So what is the use case
Hello.
of is
Yeah. See, use case is that to accommodate the joins. Okay. For example, you say, as I already said, some all other big tables, all the data is present in all other nodes, right? All other nodes, right? For example, you take a customer table with 100 million records. That is even distribution style key. All the data is present in all slices. But if you give small table like which has only some 100 records, but this data is there only in few slices. It's not there across all the nodes because the data is very less. So at that time also during the query processing, it has to duplicate the data in order to join with all the data that is present in the other table. Okay, for example, you see you have employee table and department table. Employee table has maybe 100 million records. It is there in every slice of all the nodes. But department table maybe hardly it has some 10 records or 15 records because generally among 10 or 15 departments will be there, or even let's say 20. And these 20, but all the 100 million employees will work to one of these 20 departments only, right? Yes or no?
yes,
Yeah. So if you then how that all the 100 million records will be joined? Just because you see, for example, just because the department table is not present in, for example, take node 1, node 2, right? Let's say there is a node 10 is there. Just because department table is not there in node 10, it does not mean that there is no matching records. Yes or no?
yes,
So even at that time also, employee table has to look for where is this department table. I need to compare all my values and see for the matching values. It should think like that, yes or no?
Yes.
So in order to avoid that situation, the small tables will be placed in every node. Every node means first slice, so that it can locally check and bring the matching records.
Okay, so slice 1 can check for the slice 0 data.
Yeah. That will be locally available in the node. Yes.
Oh, okay. But how it will know that data is present in slice 0, or it initially looks in locally and then goes like what is?
It will know because it knows that the table has distribution style all right.
Okay.
All means, yeah, this is what the later node. Later node, it has all the data dictionary, right? Means it knows everything, what tables are there, what these are all called statistics. What is the distribution style? So based on that only, it will give that plan. Yeah, all means yes, that is locally available. So you don't have to look for other nodes, and you don't have to distribute this data to other nodes, or you don't have to bring data to intermediate place, means outside. So you can check the copy that you have already inside you, like that. It has all that information because it knows that this table has all distribution style.
Okay, so sir, just trying to summarize, can correct me if I am wrong anywhere. So all data distribution, all we will use in case of small tables where we will be joining with the larger tables. In their scenarios, this will be useful. Data
I mean,
distribution,
no,
all.
you should not mention in case of joints and all. That is automatic, okay? But that is default. Why tables will be there? I mean, generally we join tables, right? So that is automatic, okay? That will help, okay, for joint processing. I mean, that
So if
is
they
alone
ask
enough.
where we'll use distribution style, all we'll say in case of creating small tables. That is what we
Yeah,
will say.
all is good or ideal for small tables like dimension tables. Generally, in the real time, we always talk about facts and dimensions, right? So, yeah, all is good for small tables or any small dimension tables. Bus generally, or you can add generally dimension tables are small in nature. So yes, and of course, if dimension table is too big, for example, customer is also dimension table, but it's too big. Okay, dimension that's why I said all is good for small tables and for any small dimension tables.
Okay.
Okay,
And sir, what for the other ones, like when we'll use even and when we'll use key?
I said right. If you know the primary key or if you know the joining column of a table, then yes, distribution style key should be used. In fact, you should always look how the key should be used. If you know a table and if you know its primary key or distribution, I mean primary key means the column which is most unique, right? And if you know the based on which column it is joined, yes, you better to create it as the distribution style key.
And
Okay,
if we
and you
don't
already
know,
know that, yeah, if you already know that this table is big, then distribution style key. Okay, yeah, next tell me. If you don't know the joining column, is it?
yeah, correct.
Or if you don't know whether it's a primary key or not, is it?
Yeah, then we'll use even. That is what I was going to ask.
No, no. Even if even if you don't know whether it's a primary key or not, that's fine. But if you know its column is used in join, then you should define it as the distribution key. Even if you know if it is used in the joins, then you should define it as a distribution style key.
Yeah, distribution
Okay.
style even when we'll use.
Even I said right, it is the last. Generally, the history tables which are not used in our regular query processing, because even is not good for performance. It is only to distribute data evenly. That's all.
Okay.
Okay. So generally, the history tables which are not regularly used, you can define it as even. so that data will be stored evenly, so without any data skew bus. And it is the
what help
last
it will
option
do?
that
So if it is done in a history table in an even way, what help it will make? Because history table will be querying and it will be large, so that it will be, is it right?
history tables are not used much. Okay, I mean they are, we see generally, let's say we have, I'll tell you in real time what happens is, there are some, I said right, there are, we will maintain history for 5 years, 10 years, 20 years. So we don't keep all the 20 years data in one table. We always try to keep maybe, current year plus last 1 year or 2 year or 3 year or 4 year. I mean generally current year plus last 3 years data in the table which is regularly used. And the last, I mean other data like fourth year, all the data we'll put in one history table. That's all. We never touch it unless it is very rare, maybe for some purpose. Then one time we will be querying that. But I
Yeah.
mean that is only one time usage. But generally all the
Yes.
frequently used data is there in one table. That is along with current data.
Yeah. So what help it will do if we make history into event distribution? Sorry,
Yeah,
I am
what
asking.
help? Yeah. What help means it will evenly distribute the data, so that generally what happens is, I said right. If it is not evenly distributed, what happens? What happens? One, I mean, one slice will have 75. For example, the same example, 100 is 75, 55. 75, 55. I mean that yesterday's example, 75 records 5555. Okay,
Hmm.
55
Yes.
plus 175. So skew will be there. It will avoid skew basically. Okay, so one slice will occupy more of that node resources whenever that table is queried, and that will skew up the entire system performance. You understand? Whenever the table is queried, it will screw up the entire system.
When the table is queried, it will search.
It will screw up. It will
Okay.
kill the performance of the entire system.
Okay.
Because, I mean, especially it's history table and a lot of data is skewed. So only that node or that slice is busy. What about other regular running queries? They will be seriously impacted.
Yeah. Correct.
Yeah, and that too, because it's history table, once the operation started, in between, even if you abort also, abort will not be much immediately effective because it's already in the middle of the some process.
Yeah. Yep.
All other queries will be impacted. So that's the reason it will be even, means at least it is evenly distributed. So at least when anytime when you query, at least all the amps, I mean all the slices will work and try to complete that work. Basically, history tables are not used for query processing. Okay, to avoid this queue only, we will create it as an event distribution style.
So what was the fourth one? All even key, and another one is
Auto.
auto. Auto is by default. Right?
Yeah, you don't define anything, it will take auto.
In auto, what it will happen is first it will go for all, and then it will go for even. That is what you said,
Then
right?
it will convert. Yes, it will convert all to even. Once it does, it knows that this table is going to grow.
Automatically. So if I create a table today, it will first create it in all mode, and later on after 10 days, if it sees that the data is growing, it will automatically convert that data into even. That is what is correct, sir?
Yes.
Okay. Yes, sir. Sorry, I was having doubts. So thank you, sir.
Yeah. You are clear about even, right? Even.
Yes. Even is only if it is a historical data, and we know there is lot of skewness in the data. Then large table. So then in that case, we'll store it in event mode so that each node, any of the nodes are not blocked with a huge data which is not used in regular way.
Yeah, even is basically to avoid this queue. Okay, and that too, if you don't know its proper distribution key and all. If you know the distribution key, okay, I mean, if you know its primary key is alone can evenly distribute, then you don't have to go for even for history tables.
Then generally, day-to-day work, which are the most used distributions?
I mean, I will come to this point. You understood about even?
Yes.
Even say, for example, you take customer table. Customer table can have 100 million records. It does not mean that for history table of customer you will create even. No, you already have customer ID which can evenly distribute. So at that time, you don't have to create history table of customer table with even. You will create it with distribution style key only, even for history table of the customer. You got that point?
Yes, I got that. Yeah, I got that.
Yeah. So if
Only
you
there is
don't know,
skewness. Yeah.
if there is a skewness and if you don't know, okay, what is the column that can evenly distribute, especially for history tables, yes, at that time you will create it as even and keep it aside bus. Okay.
Yes. Yeah.
Yeah, now you're asking something, tell me. Yeah, mostly which is the one which is used, right?
Yeah.
Yeah, distribution style key. That's what actually I made this point. If you know any column which is used in joins, or if you know which column will evenly distribute or which column is used in joins, you always try to create as the key.
Okay.
Okay,
So
so that
key
is
is
the most
something that
used.
is mostly used because people will be using joins mostly.
Yes, yes. Yeah, key is the one. In fact, we should also prefer to create with key. We should know what is the joining column that is used and try to create distribution style on that. Okay.
Yeah. Yes.
Tomorrow I will ask one question. Try to find an answer. A table has, a table has, I mean, it's too big table, very big table. It has a column which is 100% unique. Okay, a table, I mean, it's too big table. It has a column which is 100% unique, but not used in the joins. But there is another column in the same table which is 80% unique, but used in the joins. Okay, which column you will choose as the distribution key? Why? That is the question. You note down and tell me answer tomorrow. Okay, a
So the
table is a big
column
table.
that is used in joins, we'll use that as a distribution.
Yeah, that is the answer. Okay, that is the correct answer. My question is why? Yeah, this is the next question. Why? Okay, you please answer it. Yeah, answer it if you know. I can listen.
Yeah. So if there is a column which is 100% unique, and if it is not used, so then there is no use of making that as a distribution key instead of making the other column which has 80% uniqueness and 20% there is skew. So instead, if we use that as the distribution key, so it will help in our day-to-day activity with joining while joining the tables and getting the data because it is being used frequently. And the other one which is not being used, that's I think that is not an issue because that data, even if it is duplicated in because yeah, when it is duplicated in different slices, it will not be a problem because we are not using that to do the computation. The main purpose of distribution is to achieve the performance.
Yeah, that's right. But yeah, now he will ask this question in the interview. You consider it as in the interview, yeah. So then tell me how is this column on the joining yeah will help you for the performance. or why the other column which is most unique? Because most unique means it is the one actually evenly distributed the data. Why? How can it cannot help you? Or where is that you are getting the benefit? You tell me. I'm looking for that. You will tell like this.
Yeah, correct. So in that scenario, if we are joining with the column, if we are making distribution key as the 100% unique column, so in that scenario, it will come to a scenario where it will be say 25, 25. If it is 100, if I then in that scenario, it can be like 25 seconds it took for one slice, 25 for another, and another might take and 40 seconds, and another might take 10 seconds. So ultimately, the overall time will increase to 40 seconds, which would have been achieved by 25 seconds.
No, you see, my
Um,
question is, I'm asking, just show me where is that you are getting benefit by creating joining column as the distribution style, rather than the column which is 100% unique as the distribution style. Tell me how is that helping you?
okay.
Because you said the 80% column as the distribution style is good and good, you said, right?
Hmm.
So I'm asking, where is that it helping you, or why you are saying that as good?
Okay, so let me think on it and I'll answer it tomorrow.
Yeah, you answer. Yeah, it's a very critical and the most important question in the entire IT career. Okay, so especially the distributed systems and performance optimization. You are clear, right? My question. There is a table, big table. It has hundreds of millions of records. In that, there is one column which is 100% unique but not used in the join. And there is one more column which is 80% unique but it is used in join. So which column you will select as the distribution key and why? Okay, yeah, you think and answer me tomorrow. We will answer this tomorrow and we will discuss the underlying theory or underlying what is going to happen or why it is beneficial. Okay,
Yes, sir. Yeah.
okay, cool. Thank you. Thank you. Take care, both of you.
Yeah. Thank you, sir.
Yeah.
Thank you.
Okay, sure. Take care. Bye.
Sir, can you share the recording so that I can go through and today night?
Yeah, I will share it.
Yeah. Thank you, sir.
Yeah.